Assalamu alaikum students and welcome to Slate. This is Khawaja Yasin and let's study chemistry. What we have observed in the recent years, and I guess since the time there has been A-levels, that students always find difficulty in the P5 paper. Now the P5 paper is the easiest of the exams. Like, I don't know why do the students feel scared of that. There is nothing in P5, especially when you have attempted P3, when you have practiced those experiments in the labs. P5 has no difficult questions. There are a few precaution questions or reasoning questions of 1 or 2 marks. Those are the trickier ones. Rest of the paper is mostly based on your P2 or your P4 and majorly on P3 because it is related to P3. In O-levels, most of you attempted for P4, which was, and the IGCSE students went for P6, which was the ATP, alternative to practical paper. P5 is exactly the same ATP, but obviously on an advanced level. So now, when we talk about this paper, P5 chemistry, 9701, and the title goes as Planning, Analysis, Evaluation, and even the trickiest part of chemistry, calculation. So, when we talk about P5, there are not many concepts that you need to recall. There are only a few concepts and there is no particular syllabus for that. All you need to do is practice a few papers with me. That you have to do it, but with me, with Slate. On Slate, we will assure you that we will revise maximum past papers, especially in the upcoming session. That we're done with 98% of the practice. Why am I saying 98? Because every year, those 1 or 2 mark reasoning questions, they can be a little tricky. They can trick you a little. So, out of 38, you can easily score 27, 28, but you can even score 30 marks. That's again, the more we practice together, the better you can score. So let's talk about this paper. What is there in P5? It's a 30-mark paper and it has 2 questions. Now, one question is for the planning part and the other is for the analysis and evaluation. Like, what do I say? Normally I tell it to my students that if you are performing P3, the laboratory experiment, the planning part of P5 is something before that experiment. Like, you plan an experiment, you selected the apparatus, you made the solutions. That was before you performed a practical in P3. So question number 1 is the planning part, which you do before performing a practical. And question number 2, the analysis and evaluation, that is done afterwards, after P3. So this is what it is all about. It's a very basic one, especially if you have a good grip on P3. Now students, even if you do not remember formulas from P4 or P2, in P5, they give you the formulas themselves. So you have the formulas. All you need to do is just do the calculation, make the gradients, make the graph, make the dilutions, make the apparatus, choose the apparatus. The most important concept again and again, as it went in O-levels, now in A-levels, it's moles. There are definite questions for moles in P5, especially in the planning part, because you have to make a solution. So, N equals to C into V, concentration into volume, or mass into MR, mass divided by MR, because obviously they're different practicals. So, when we talk about the approach towards P5 for students, there are 2 approaches. One is for the students who are going for composite exams. So the students going for composite, P5 becomes easier because You're doing practicals, which we will be performing on the platform of Slate this year as well, and you just you just attempt a similar P5, a similar practical you've done in the lab, and a similar practical you're planning and evaluating on in this paper. So that makes it easy. But if you have done all the P3s before, so P5 you just have to remember a little much. There'll be all the procedures given to you. They will skip a few steps in the planning part, and then they will ask you that why did it go wrong. So that is what we know about P5. So if we talk about the planning part, now let's quickly discuss what will we have in the exam. Obviously, we can't discuss it all. Why which apparatus is important, what is percentage error, how do we talk about variables. But in today's video, we are going to talk about the variables and the graphs. These two are important questions, always there in every exam. So at least in this intro video, we're going to talk about these two. But first, when we talk about planning has various parts: variables, apparatus selection, measurement. Mostly this part is restricted here. And then there can be reasoning questions like safety precautions, how to perform. These questions become easier for those students who have attempted P3, because these are all related to that. So your memory will help you a lot. And if you remember, there are questions at the end of P3, 1 or 2 mark questions, when they ask you that why did you do that? Why did this happen? So that is what you do while performing a P5, while attempting a P5. We don't perform a P5, we just attempt a P5. So first, when we talk about apparatus, you know about the apparatus very well. Let me show you what are the apparatuses that we are going to be dealing with. So first of all, stand with a clamp. We mostly use it for a burette, just to place a burette here. This is the clamp. We adjust the clamp according to our size, because for burette we need to see the meniscus, the reading. That again we will be discussing. Crucible for strong heating. If you remember, crucible is used for hydrated salts, mostly for water of crystallizations. So you need to link all these. So crucible is made up of ceramic. It can resist strong heating, otherwise glass will break, and it can absorb. So crucible is for strong heating. Pipette. In chemistry, we assume that a pipette is shaped this way and it has only a mark on 25 centimeter cube. Normally in the labs in our schools and colleges, we have a volumetric pipette or the graduated pipette, which have all the readings like a burette. But we assume that we don't have it unless they ask you how to measure 19 centimeter cube in a pipette. We use a volumetric pipette. But mostly the pipette for us is 25 centimeter cube. Very accurate. It's accurate and it's fast. Burette. Again, if you look at the readings, 0 and we have 10 centimeter cube. So the minimum volume that a burette can measure is 1 centimeter cube. So burette is highly accurate. So burette is highly accurate, but it's slow. You add drop wise. So we use it for, but again, for any reading more than or less than 25, we use burette. Because when we talk about 25, pipette is the best one because it's fast. Even burette is more accurate, highly accurate, but it's slow. So burette can also be the right answer for 25 centimeter cube, but pipette is a better one. Measuring cylinder. Sorry, my apologies. This is 0.1 centimeter cube can be taken with a burette. Measuring cylinder can take 1 centimeter cube reading minimum. But again, it's easier. You pour it something in it and you just take it out. So that's again faster. So for the calculations, when volume is not of much importance, then we use measuring cylinder. Volumetric flask, again, highly important for dilutions. Just like pipette, this has a mark, a 250 centimeter cube mark. We don't have any other markings. So we just keep on adding water with a funnel and we raise it to this mark of 250 centimeter cube, highly accurate. For temperature, it's thermometer, round bottom flask. For various experiments, conical flask. The best thing about these two apparatuses are when you stir something in it. So at the base, the surface area is higher, but top, the mouth is smaller so that your solution doesn't spill out. So that is where this apparatus has important function. Evaporating dish, you know, it's very important again for heating, again for crystallization. Watch glass. Beaker, just to keep reagents. No reading, no nothing, faster way to transfer. Wash bottle, it's a pouch-like bottle, has distilled water in it. Gas jar, rarely used. And the next one, more apparatuses. So gas syringe for gas calculation, gas collection, we also use the inverted measuring cylinders, the gas collections, the upward and downward displacement methods. So that is also used for gas collection, but gas syringe is more accurate. Stopwatch, now we don't use analog watches, we use the digital ones. That's accurate, better decimal points. Pan balance or electrical balance is used. We tear it in the start. We will discuss all these one by one. Stopper, gauze and tripod, a very important one. When we are using crucible, we can put the crucible here and then we do strong heating. But when we are using a glass apparatus, we first put the gauze here. Gauze is just a metallic frame. You can put any glass on it, it won't break. There will be lesser heat towards it, but it will still be heating. Test tube, again, condenser is very important. Thistle funnel is very important in many reactions. Separating funnel, metal, tongs, spirit burner for slower ones, spatula for transferring solids, test tube rack, and Bunsen burner. So now an important thing. Bunsen burner is placed under the tripod. There are 3 types of heating methods. Bunsen burner, mostly used, but not for flammable items. Then we have water bath. We heat the water and we place something in it. So this is safe, not flammable, but limitation. Is 100 degrees Celsius. Why? Because at 100 degrees Celsius, water is going to evaporate. You won't be left with anything in the tub or beaker. So water goes away. So in that case, when we have a flammable item and it needs temperature more than 100, heating plate or electric heater, we electrically heat it. So that is the apparatus. We will be talking about this apparatus more. So that is when we talk about the apparatus. This apparatus is very important. You need to know the measurements that an apparatus can have, the capacity. For instance, a burette is wrong. The answer should be 50 centimeter cube burette, 20 centimeter cube pipette. That's how we use the values. 250 centimeter cube, volumetric flask. So this is important because then they ask you to explain how will you make a solution, to explain how will you make it more dilute. So dilution is very important. That is something you have studied in biology especially. C1B1 into C2 V2. Same moles concept, N equals to C into V. So this is an important formula. You have a particular concentration, you have a particular volume, then you have the concentration for the next one or the volume for the next one, you will find out the concentration. Again, these are just formulas. We will be discussing them in the class. So most importantly, the last thing about today, before we talk about analysis which has graphs, before we talk about graphs, we need to know the variables. There are three types of variables. Independent, dependent, and controlled. Independent is the one that we change during the experiment. So when we change this independent variable, the dependent variable's value is also found out. Let's discuss how. So dependent, that we measure, and control, that we keep constant. So for instance, when we are talking about the rate of reaction, if I am finding the rate at various temperatures, so students, since I am changing the temperature, temperature will be my independent variable. Since I am changing it. Thanks to the changing temperature, I am measuring the rate of reaction. So if I am measuring it, this is my dependent variable. And what shall be the controlled one? The volume, the concentration, because we are not changing the concentration. So that's how you keep on doing that. So anything which is not being changed, we are not even talking about that in the question. That is the control variable. Now, these two are important ones. When we draw a graph, remember one thing. Independent variable on the x-axis, dependent on the y. Now this is where we talk about the analysis and the evaluation part. Graph is highly important in this part. So for instance, you've been given values, you've been given a table. They give you the formula to find out the missing values. The formulas are there. You just have to put the values in the calculator. 2 marks for that. So that's very easy for you. So now, when you have found out the values, you incorporate the values in the table, in the graph, for instance. We have a graph with us. The last thing about today, students. This is from one of the past papers. So what do you see? Molar conductivity is being calculated. So this is a dependent variable. And this value, when we talk about, we have the square root of concentration. This can be the value of K. That is the independent variable. So for instance, let's just plot a graph randomly. You use these crosses to plot a graph. The line of best fit can be, for instance, if I make this line, I call it the line of best fit. It should have equal points above and below the line. So apparently it looks like a line of best fit, apparently, just wait, because that's how it is. Let's make another point here. Yeah. So that's what it is about. It should have equal points on both sides. But again, this is a highly wrong line of best fit. We try to take it this way. Now, if I try to draw a line of best fit, there are points which are not being involved. This point and this point. So we need to have maximum points being involved. And then what do we see? That this might be the anomalous point. So this is another important question. You need to find the gradients. Like they would ask you to find the gradient. They would ask you to find the anomalous point. And most importantly, they will ask you to tell the reason about the anomalous point. Now, why? Because since we are calculating this point, and this is the concentration, so we were wrong in calculating the concentration. We measured the concentration too late. The concentration should have been here at this point. So we were wrong in calculating the concentration. So we blame the x-axis towards that. So the concentration was taken wrong. It was taken late when it was more. Or there can be any error. Since the concentration is lower because it's a reciprocal. So hence at this point the concentration was lesser. Because this is a reciprocal one, concentration is in the denominator. So we say that the concentration at this point was lower, not higher. So that is what you tell about the reasoning. Then you just choose 2 points for gradients, 2 random points, and you use them in a formula, and then you do the percentage error. We will discuss that in the classes. So students, I know this was a rushed up video, but this is the whole picture. It's a 30-mark paper, 2 questions. The marks can vary. It's not important that compulsory that it's a 15 marks. They can vary. They can be 18-12. They can be 15-15. They can be 16-14. But if you have these things on your fingertips, these are always repeated. These concepts are always repeated in the exam. So getting an A star in P5 is the easiest of the things. In the threshold, A star is on 26 out of 30. I am telling you that getting 28 or 30 is not a difficult deal. So this was an introduction for the P5 sessions that we are going to start next week. So hopefully we'll see you all there in those sessions, and they will be fruitful for all of you and us together. So we will be practicing different papers. We will be discussing in-depth concepts of P5 in those sessions. So hope to see you all there. You can call on the given number in the description of the video so that we can do it together, because this is Slate, one click away. Thank you so much.